Good morning. I hope everybody is feeling well. We have quite a big lesson today. This is the beginning of the unit circle. Just about everything we're going to do in the trig unit is going to refer back to the unit circle and what we're going to talk about right now. Very, very important. So please take notes on this and please email me any questions you may have. All right. Before we can even get to the unit circle, which is our lesson 3. We have to talk about a few important things first. The first important thing we have to talk about are the special triangles going back to geometry. And I don't know if you know them. I hope you do. But let's go through them from the beginning. Special right triangles. Okay, the first special right triangle is the isosceles triangle. So isosceles, of course, has 2 equal sides and 2 equal angles. And if we draw this out, the equal sides are the legs, and we're going to call this leg 1 and this 1. These are also equal angles. They're 45 degrees and 45 degrees. And this goes along with a few theorems. First theorem, the sum of all angles of a triangle must equal 180 degrees. And the second theorem is saying that congruent angles, sides opposite, are also congruent. So here we have our isosceles triangle and tying it back into geometry. Now with the Pythagorean theorem, if we wanted to find the hypotenuse, we would use a squared plus b squared equals c squared. And the altitude here is 1, and the base here is 1. And now I'm looking for the hypotenuse. So 1 squared and 1 squared is equal to 2. I want to cancel a square. I'll use the square root, and the hypotenuse is radical 2. So the isosceles triangle, the base isosceles triangle, will always be 1, 1, rad 2. We call the isosceles triangle the special triangle. We call it the 45, 90 special triangle. Now, why is this so special? Well, 45 degrees is half of 90 degrees. Really, really important. And if you think about your sine, cosine, tangent function. So now we're going to tie this back into when you did sine, cosine, tangent, your teachers probably gave you SOHCAHTOA. I write it like this. SOHCAHTOA. Because now it tells me the ratio of my sides. The sine function is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent side to the hypotenuse. And tangent is equal to the opposite side to the adjacent side. And one of the most important things you're going to see with tangent, look, it's opposite over adjacent. Sine is opposite to the hypotenuse and cosine is adjacent to the hypotenuse. So here's a new one. Tangent is actually the ratio of sine over cosine. Tangent comes from sine divided by cosine. And that even goes back to if I put in that sine is opposite over hypotenuse. And I put in cosine is adjacent over hypotenuse. This brings us back to complex fractions when we did the ratio, the rational unit with all the fractions. Look at, they have a common denominator. Denominators cancel. Brings us back to the opposite over adjacent. Brings us back to here. So this one is super important. So I hope you wrote this down. This is like tremendously important. Whenever you want to know tangent, you can just find sine and cosine too. And most of the time you're going to be given sine and cosine. So sine and cosine are the most important. Tangent comes from sine and cosine. So now, how does that tie into my special triangle? Well, I'm going to have to do a little bit of erasing. So I hope you wrote this down.